Dutch fashion tech designer Anouk Wipprecht creates designs ahead of her time, combining the latest in science and technology to make fashion an experience that transcends mere appearances. She wants her garments to facilitate and augment the interactions we have with ourselves and our surroundings. Her spider dress is a perfect example of this aesthetic, where sensors and movable arms on the dress help to create a more defined boundary of personal space while employing a fierce style. Partnering up with companies such as Intel, Autodesk, Google, Arduino, Microsoft, Samsung, Adobe, Adidas, Cirque du Soleil, Audi, Disney, Swarovski, and 3D printing company Shapeways, she researches how our future would look as we continue to embed technology into what we wear, and more importantly, how this will change our perspective on how we will interface with technology.
Thank you so much for the intro. That was a full intro. Cool. Thank you so much for hosting this on Saturday. I'm gonna just see if I can share my screen with you guys, and I'm gonna show some of my projects. And I will speak for about I think like 30-40 minutes. And then if you have any questions, yeah, drop them in the chat, so I can answer them as well if we have some time left. So I'm from the Netherlands. I don't know where everybody here is from. I heard in the intro some of you were from New York, from the USA, and I'm from the Netherlands, and I moved to the USA in 2012. So I'm now out here, and yeah. You can find me on under my name, Anouk Wipprecht, which is a hard last name to pronounce, on social media. And the first part, I'm going to explain a little bit what I'm doing, and then yeah, talk about some of sort of the research and design, and the process of working with both fashion and also with electronics and technology. So the dress that you already named is the spider dress that you can see here. So it has mechanic legs on the shoulders, and it works with proximity sensors. So there's basically proximity sensors in the front, and those proximity sensors, they measure up to 25 feet. And the cool thing about this dress is when you walk into the personal space of this dress, the sensors can see that, and the dress is attacking. And it literally attacks because it has proximity sensors, and then they are reacting to servo motors. So on the shoulders here, you can see all these spider legs. They all have, each leg has like a little servo motor involved in there. So which you can see here, this was one of the prototypes. So the servo motor is in here, and that's the one that I can then control. So there's two in these little parts. So two sandwiched there and one here. So that makes an like movable structure, sort of, you know. And that's kind of cool. So I do things with like robotics, and other than, we always tend to model our robotics after humans. I like to model my robotics after animals, like the spider with a sort of almost a cat-like behavior, and then also place it on the body, sort of, you know. So a little movie that I have here shows you a little bit the interaction of the movement. So whenever, you step into the personal space of this design, it notices that, and then it reacts. And that goes into this notion of like, the spaces that we have around us. So here you can see the intimate, the personal, the social, and the public space. And these spaces we have all around us. And that is something that fascinates me because if you look at different cultures, we are behaving differently. We are standing closer together or further away. As I mentioned, I'm from the Netherlands, and they're pretty cruel sometimes. They are very fast, very close by, whether in America, for example, you know, people are a little bit more elegant of keeping space. And my dress is seeing that. So my dress is reacting much faster and much quicker in the Netherlands because a person walks much more fast and more close by because the dress is noticing this. And if the dress would just only attack in one state, it would be not super pleasant sort of. So this is why if you're looking at the interaction design behind it, it's really important to look at that it can behave in different ways, which it can. And also it reacts in different ways based on the data that it gets basically. So the sensors are measuring up to 25 feet, which you can see here, which is about 8 meters. And this is called the proximity theory, or proxemics, from Edward T. Hall. In the 60s, he wrote a book called The Hidden Dimension, and he was noticing that, people have different personal spaces, and he wrote that down in his book. He was using a stick, like a wooden stick, to measure these people's personal space. So when I found out about this research, I thought, hey, that's interesting because it has a direct correlation to the body. And the other thing is, well, I was busy with sensors in the beginning of 2000s. About 20 years ago, I started with this. I'm 34, I'm 35 now. So yeah, 20 years ago, I started with getting into electronics and all of this stuff. And I thought it was interesting what he was measuring in a really analog way I could do using sensors. So I did sort of. So here you can see a little bit of the design. In this case, sometimes I like to really showcase all the, sort of all the motors, all the wires and all of that stuff, all the things that I'm using. And other times I like to hide it because I don't want to show any of the electronics. So that's kind of a cool play what you can do. You can decide if you want to show parts of it to make it more nerdy, make it more witty, or make it more understandable. In this case, I really wanted to show where everything goes, where the sensors go, and it all mounts into the back piece where the battery goes and all of that stuff. So that you can see here. You can see the 3D printed legs on the shoulder. In this case, it was for a presentation, and I thought it was fun to also make these robotic spiders, and they were like walking behind the dress, and we used them at maker fairs as well. So some of the design, I come from like a sculptural background. If you look at getting into like 3D design, this is very complex design, and it took about half a year, so longer time. You can model something now. You can use Tinkercad, for example, to start modeling. You can use Fusion 360 or different kinds of softwares in order to get a feel for it. There's an open source software, free software called Blender, which you can look at. But it's all about like just making something, whether that is like a leg, whether that is a part, whether that is a full dress, or maybe a fabric. It's kind of cool what you can do if you print on an existing fabric or a mesh. You can do a lot with like 3D printing upon that sort of. This dress is very complex, and it has a very sculptural character with a lot of like things intentionally taken from the body, like the eyes of the spider being the sensors, the kidneys, their respiration sensors inside, and also just the notion of this dress have maybe eaten something, you know, you see the vertebrae and all of that stuff, and bones and all of that stuff. So definitely I wanted to create a more eerie kind of representation, because when you interact with it, it is literally attacking you, sort of, you know. So that's kind of, an interesting point for me in the notion of, sort of interaction design. So some of the steps is like trying to make it comfortable around the body. It looks like a lot of volume, but there's a lot of void space inside. So it's actually a really light design, while you really want to make it like full, almost that corset body, and also the shoulders with all those legs. So it's really about conforming into the body. In this case, it needed to lean almost in a 90-95 degree angle on the shoulder, so it would stay comfortable, and also the mechanics would be able to work however you would be moving, sort of. So that's always part of the research, like how does this, whatever you want to do, conform to the body, whether it is LEDs, it is robotics, it is smoke, whatever it can be, sort of. And that's kind of the interesting part about that. So this I created when I was working at Intel in 2015 in Oregon, in Portland. And here you can see the dress and also the spider. And here you can see the spiders. Even this, you can see the Intel Edison that we worked with from Intel, not even like anything on it. So you can see all the wires, and they were dancing. You can program them to dance. That was kind of a cool thing. So yeah, I started with big computers on the body in the beginning of 2000. Was cool, but not really really practical, and not really sexy neither, because something looked nice from the front and you turned around and there was this big computer on the body, sort of, you know. So in 2005, people from Italy, they created this. It's called an Arduino. And it's allowed for people to basically code in a much simpler language than C++, for example, or whatever you would be using at that time. It was a derivative from C++, and it was just really easy to step into, but it was also really small. So Arduino really made a big difference in, say, 2005, 2006. This is basically, if you are coding things, let me just see what I'm doing here. These are just some servos. It's just like single servo. There's a lot like online from GitHub to Instructables to Hackster.io if you want to get into coding. But yeah, just buy an Arduino, and you can buy them at SparkFun or Adafruit, or you can find them online, and you download this free software and then you can start to code. I think an Arduino is like, $20 around. So yeah, what Arduino did was really making electronics fun, in where before that there were like big computers or very nerdy stuff, sort of, almost. So what I do is, and the tools that I use are 3D printers, my laptop to design, to program, to communicate, my sewing machine to create, construct, and to produce, my soldering station to construct, compile, and engineer. And those are the things that, even this is my home, what you see behind me, and I want to be able to just step out of bed and do stuff, even if it's the middle of the night. So I have a tiny laser cutter here, and I have my 3D printer here, and you can see my spider dress, and behind that is my soldering station, and I have like a sewing machine here. So basically I have a studio, and I also have the opportunity to just step out of bed and to make stuff here as well whenever I want to, sort of. And that makes it just, it makes it really fun. It's nice to work with like multiple media, I think. So another dress is the smoke dress, which is much more friendly when you look at it. It has this pear-shaped design, and when you interact with it, it's also much more friendly. It puts up a smoke screen as if it's getting shy, you know, the emotion of maybe shyness, of diving away. And this is based on another animal, which is the octopus, which pushes out ink, and then it can basically dive away. So that is the same with the smoke dress. It's based on sensors, and it senses the amount of people in the direct environment of the dress. And when there are more people, there's more smoke coming up, sort of, you know, so she really disappears behind this dress almost. And that is also a 3D printed dress that I created in 2009, materialized. And that was the first 3D printed dress that I did. So that's about, say, 12 years ago that I start designing this. Was in an exhibition. I think the cool thing about this dress are the hip areas, in where I try to see if there could be like a space in the hip area, so we could push in the smoke and it could escape through the sort of the holes in the sides. And that was the first time that this process came about. It's selective lace sintering, and this is a TPU. So this is 12 years ago. So that was a fairly new thing, but it's a rubbery material that you could print in, which make more flexible, where this was this more flexible part in the front. So that was a showcase for Volkswagen, for the car brand. So there were multiple designs, and it was running for, I think, like 4 or 6 days, 6 times a day. So it was all controlled through the DMX control, the light control of the space. This was in 2012. and that were all like on based on electronics and wireless control, sort of. They were controlled over XP, so Zigbee protocol. And so this is a dress that I created for Cirque du Soleil. It's a robotic cocktail dress, and it really makes you a cocktail by the push on a button. So it's kind of a funny twist on a robotic cocktail dress. It was made for a restaurant in Ibiza called Heart Ibiza that was created by Cirque du Soleil. And this was basically the prototype in order to see how and what. And the people that were walking around, boy and girl, they were like serving little shots of drinks. So this was the pink version. They were like in gold, in white, black, and so they had the 3D printed logo in the front, which also served as a cup holder. So I'm using a peristaltic pump. So it basically converts the liquid in the hip, little flasks, to the top part into the drink by, in this case, push of the button. So these peristaltic pumps are from partly Robotics, is the brand. And also walking around were girls that were shooting bubble gum out of their shoulders, which sometimes didn't work so well in the restaurants because it was shooting pretty aggressively. But it was it was a really fun time of like playing around with electronics in a restaurant setting. And it was 2015. So basically my questioning is, if and when we place technology on the body, what does it do? So how can it become more social, more playful, like the cocktail dress, more defensive and behavioral, like the spider dress, and more expressive and emotive, like the smoke dress? And really seeing fashion as this interface combined with electronics. How can it communicate something from you? How can it express you? How can it measure you, you know? And there are so many interesting things that that you can do by the combination of electronics and the body, and especially looking at the spaces around you, what you can do with that, or also using like body sensors in order to to measure sort of your own body signals, which I will tell a little bit about later. So this is the proxemics theory, and Edward T. Hall, the book that I referenced to, The Hidden Dimension. I mean, it has been argued many times, what if people come from the back, and what about women, and a lot of this stuff, but it's a little bit the basics theory that he came with, and then got criticized on many topics. So also, the other thing is measuring the space around you, which I explained using the proxemics theory, also body signals. So you can measure a lot of like interesting things from the body, EEG, so the brain signals, BVP, so your blood volume pulse, EMG, muscle contraction, so the way we twist our muscles, you can do a lot with EDA, galvanic skin response, the sweat levels of your skin and how your skin is reacting, respiration, so your lung volume, which you can best measure here, like around in a simple way, accelerometer, like the place in space of your body parts, and then HRV and ECG, which is your heart rate and also the volume of your heart. Next to temperature, oxygen, all of that stuff. So there's a lot of like interesting things that you can take from the body. So my process, this is one of the dresses that I created about 15 years ago, which is called Pseudomorphs. I wanted to create a system that would be, in this case, dripping ink on a dress and absorbing it. My inspiration came from this notion of sort of a utopic view of a drop of ink in water, and the twist that it makes, I think, is really interesting. So the little dance that it makes. So in 2006, I started to research of how I could translate this into a dress, and then later on I was starting to build it. So the first step that I want to do is like document what I think is interesting, having that put in a picture. In this case, I transfer that to sort of a sketch or like Photoshop things together. This was one of my models, Aleida. So I let the model stand in a certain position, or I take a photo from the internet or from myself or something, and I just try to recreate, okay, is this what I want? Should it be going out, or what do I want? And that is functional for a sketch. This time I just put it in there and I was like, okay, this is what I want. But I have times, if I work for clients, I might make 60 sketches, or 100 or 20. So it's just like, until you have the feeling for it, like, okay, what am I trying to search for? I think sketching is just really important, even if you're not the best sketcher, or use Photoshop or whatever, or make things from paper. There's a lot of ways, but I think it's important to catch your ideas sort of on paper. At that time, I was getting into tubes and solenoid valves. I went to the hospital and I said like, hey, I want to do this project. I have no idea, but I know that you probably have some leftover things that I might be able to use. And can you look in your lab sort of? And they just loved the idea that I just came up to them and they gave me a lot of things that I still don't know what it is. But I think it's a lot of like pain pumps and for medication and all of that stuff. So they were like happy to help. It's always a no you can get, and oh no, a no you have, and a yes you can get, we say in the Netherlands sort of. So yeah, I walked to my the nearest hospital to ask for that. I ended up using these solenoid valves from Vasto that you can open up, sort of, you can open them up, like control them sort of, and they were made for air and not for fluids, but I hacked them sort of and I used it this way. This one is one of the first PCBs, which was run on a 9-volt battery, and again, it's 20 years ago, so this can be, I think it can be 1/5 of the size right now and run on an even smaller battery sort of, you know, but that's the cool thing about electronics and the era that we live in. Electronics and technology became so small, but there you can see the system, which is built into the back piece, and then here you can see the some of the dresses and experiments. So I used a filled, like a wool material, because it would absorb really nicely sort of. During the presentation, the model had the dresses on and it was like being inked. And then in the end, I was hanging all the dresses around. It was for presentation at ICEA in Germany. So that was kind of a cool thing. Then I got a message from America, from Los Angeles, from a stylist called Bea Ackerlund. She was the stylist of Lady Gaga and all of that stuff. This was in 2010 or 2011, I think. And they said like, oh, we really love that idea. Can you make a similar pump system, but a little bit more crude for this thing for Britney Spears? So that is what we did with like a sort of pressure pump system. It was not, the material was not from felt, so it was not a woolly material. It was more cheap material because they needed a lot of it. So you don't see the absorption so well, sort of, but it was just a kind of cool thing. And it was, of course, also not necessarily on the body. It was a big machine that was blasting out the ink. So going to prototyping, one of the things that I always say, if I have a new material, if I have a new piece of electronics, if I have a little motor, I want to know what it does. So you can see, okay, what does it do? It moves, that's cool. But what can it not do? You know, that's what I'm always interested in. So especially with new materials, I would like to bend it, I cut in it, and I try to see what are the boundaries of this material, because then I know that I should not do that while I'm designing, sort of, you know. So here you can see me working with a PDLC foil, which is a polymer dispersed liquid crystal. We put a voltage over it, and by that it changes in transparency. So it's like a Swiss cheese almost, and the little particles, the little crystals go on its sides, and that's how you can look through it, sort of. So I'm making a lot of cuts, and I'm looking at what it can do and what it cannot do, and then I start to shape with it. And when you can see where my finger is, you can see that the material doesn't like it, because the sort of the crystals are like merging together. But I think like shaping just an autonomous form is important, even if that's not the form that you're going to use it for. It's just important to understand the material. So I'm often making like objects or shapes like that. So the first dress that came out was this one, Intimacy Black. And those was a darker material, a full dress. And then it was installed on a doll. When she was walking, it was moving, sort of, you know, which was kind of a cool effect, but she could not sit in it. So we went back to the sort of the drawing board. I did this for Studio Roosgaarden, and I was looking at the sort of an hip part, which was leather, and then the top part would be the foil, so she could just really sit and wear it and all of that stuff. So here you can see some of the moulage of the shaping that I was doing, and then installing it with the materials to see if the materials still like it, and that became Intimacy 2.0. You can find that online, the movie. It was about like, yeah, becoming transparent. It was connected to the to the heartbeat. So yeah, another thing is like research and design. My smoke dress that you just saw, the 3D printed one, has multiple lives. And that's, I think, an interesting part about fashion. Fashion is often in, and the next day it's out. And that's causing sometimes a lot of waste. And I think that's one of the reasons that I really like technology, because technology gets upgrades and updates. And I mean, I use my MacBook for maybe 3 years, maybe 5 years, you know, though it has some like electronic technology waste, it's not waste because of a trend that is in or out, sort of, you know, and that is how the fashion system has been for a very long time. Something is in, you can wear it, and something is out, you cannot wear it, so it becomes obsolete. What I noticed with my dresses is they get updates and upgrades like technology does, sort of, you know. So my smoke dress from 2005 doesn't look like my smoke dress from 2007, which you can see here, or my smoke dress from 2010, or my smoke dress from 2012. The smoke dress has like 7 variations, because when I learn more and I find some new technology that I'm like, maybe I want to update my smoke dress, and it becomes a better and a more intelligent design almost. So this was how it used to be in 2007, I think. So it was basically rolling over the dress, and the dress itself I made from resolving fabric and thread and nail polish. So other than 3D printing, I wanted to have that sculptural effect in 2007. So that's really and then also the spider dress was not always the 3D printed white spider dress. 5 years before that, in 2010, it was a black version, and it was inspired by a game called Limbo, and everybody here gets points if they know this game. It's like a side scroller, and it came out 2010, 2011, and it was about this little boy. I think I have a little movie of it, and it was walking through the shadow world. Yeah, the whole premise is was to not get killed, basically. But there was this spider in halfway the game, and I just got really fascinated by this notion. The boy walks towards the spider, and the spider tries to like sense it, and then in the end tries to pin it, of course, which you don't want. But just I like the relationship between sort of this autonomous spider leg and the boy. So what I do then is, instead of like going to engineer it in a first step, I might take paper or cardboard and first make the shape, because what I have in mind might not work, because the motors need to be a certain height, and maybe the system comes all the way here and it's not elegant, or it's not something that I want to have here. I want to have it here, sort of. So often I use like a carton box, I use paper, something that I have here, recycle stuff, and I just try out the shapes, and then I might laser cut it, and then I might work on like sort of 3D model, 3D printing, and all of that stuff. So this was more like figuring out the shape and the mechanics by pulling on threads and putting it on myself and a friend of mine, Daniel Schatzmeier, and just trying it out how these movements can be, basically. So that became the black spider dress in 2010, and it was all made from it was all laser cut, and it has over, I think, 200 screws. So one of the problems was that whenever I presented this design, the screws would somehow start to drill out. So that was one of the reasons to do it in 3D in 2015 and to create the white spider dress when we had a chance, sort of. But here you can see some of the programming of the different movements, in where, what I mentioned before, it would be really boring if it's just one-time movements, just attacking, sort of. But really looking at what are the possibilities of these legs and the boundaries, and work within those boundaries and possibilities. And in this design, there's a lot of sound, which you can hear because of the circles, which actually work really well with this design. If you want to have a design that is not loud, you might not want to use like mechanic servos, you might want to use like software. In this case, it works out really well with the mechanics. So that was the black spider dress, and this is then the baby black spider dress and the other version. So one of the things is always I write down what I think is interesting. I was working with a software engineer at that time who's working now with Autobok and with prosthetics and all of that stuff. So basically the first thing is like, especially if you're working in a collaboration, is to like write things down. Because you are starting like some like research topics that you can dive into then, sort of, you know. So I started to write out abstracts, common topics, possible interactions, and all of that stuff. And then the second thing is like starting to prototype, starting to see what you can do with it, then starting to source your electronics. In this case, a teensy, like a little computer board. and yeah, that became this this dress. So going into another topic is open source. One of the things that I like to do is like putting things online, what I mentioned before. Instructables.com has some of my projects, or Hexter.io for other people to learn. So I would put my yeah, my code on there, or my 2D files, or a step-by-step instruction on how to do things. And that's just really fun because, yeah, you're engaging with sort of like a community of other makers and all of that stuff. So one of the cool things is these students from Vienna, they started to see what I was doing with the spider dress, and they took their Lego Mindstorms and they started to like redesign the spider dress in Lego Mindstorms, and using Lego, and also using the sensors and the pot in the back and all of that stuff. And it was really, yeah, a system that was really working. So that's kind of cool. So they really like, yeah, looked this up. And the funny thing was like, when I saw it, I was like freaking out. I was like, well, it's cool to do something in like using 3D printing and all of that stuff, but you guys did something in a really hard medium, which is like Lego, you know, which you can barely form. And they were, yeah, happy that I was enthusiastic about it, because they were afraid that they were like replicating something and I might not like it, sort of. But I said like, no, I think this is great, and I'm gonna just tell everybody about this. And because of that reaction, they started to also like redo like some of the other designs, like the drink bottle dress, the cocktail dress that works with a push button. They also started to like recreate using Lego Mindstorm, which was kind of cool, and presenting it back on the festival for cocktail making robots that I in the beginning designed it for, sort of. So I think like open source is not only important to make and share with your community, it's also really fun of the feedback that you get on that. I placed electronic kitty ears online on Instructables, and every maker fair I will see like 1 to 3 people like walk around with the same ears that they downloaded for free and like soldered up themselves based on the Instructables, you know. So it's just really, or I might do the same, you know, if I find a fun project, I would make it and would be like, hey, look what I made, or hey, I think your project is great. So I think, yeah, that is the cool thing about open source and just the whole make community almost, you know, making and sharing with the community. So you can think of GitHub, which I mentioned before, for codes, make affairs, make magazine, Thingiverse is for 3D printing files. I might have made a ring and I put it on my desktop and I'm not using it. Why would I not put that file on Thingiverse for free for other people to enjoy, sort of, you know? So you can find a lot of like, yeah, 3D models on there. Instructables, Hexter.io, and also OpenBCI is if you're interested in brain signals. OpenBCI communities, brain-computer interface community. So if you go to my yeah, Instructables, I don't have too much. I should put more on there, but as I can, maybe I should go back to the drawing board and put some more on there. But the cocktail dress that I showed you, you can see step by step how I made it. EEG device, an open source dress. I think Pseudomorph is also on there. And these are the kitty ears, for example, that I just named. So the 3D file is on there. I'm giving exactly what you need to just get as components. You can see the code there, and yeah, sort of it takes you step by step how to basically yeah, make them. And so I'm going to skip this. So this is Hexter.com and the other Hexter.io, and the other project is these wings. When I was working, when I was in Denmark, I was collaborating with Lego on a build of like wings, robotic wings.
Just a couple more inventions to share with you now. These mechatronic wings won't help you take flight, but they will make you look super awesome. They're made out of Lego, and they've got infrared and ultrasonic sensors that are programmed to react to objects that come near them. The sensors work kind of like bats, bouncing high frequencies to detect objects up to 2.5 meters away. I kind of want these things. And the good news is you can make your own. They're the work of FashionTech pioneer Anouk Wipprecht, and she's recently posted a step-by-step guide on how to build them. So just head on over to our Twitter feed and you can have your own mechatronic wings.
So yeah, Instructables. So if you go there, you can just see step by step how to make them. It's a pretty big project. You need all the components and all, but yeah, it's just I think fun to just also even for yourself to document stuff and then putting it online. You know, sometimes I'm like, okay, how did I do that thing? And then I'm like, okay, it's on Instructable, so I can just download everything from there, and then I have my own notes there on how to build it, sort of. So yeah, if you want to get into electronics, what I mentioned, Arduino, Pimaroni is, if you're in the UK, Adafruit and SparkFun are, Adafruit is cool because it's run by a girl called Limor Fried, and she's an engineer. So Adafruit is definitely cool to check out. They do a lot with wearables and with lights, and getting easy way into like instructions to get into electronics. It's also SparkFun. If you need like tubes and all of that stuff, or screws, like McMaster-Carr and DigiKey Electronics for more specialized like electronic parts. So that is the end of my presentation here. So if you want to, if you have any questions or you want to get into yeah, electronics by any means, I think I sent the, let me see here, I sent